And yesterday, unless what we were working with, what was the a case of what was going on with our inequalities that we were solving yesterday? What was the new different thing that we hadn't had happen in solving inequalities before, but yet we had done it with equations? What was it?
Solving with a thing on both sides.
What's the thing? With variables on both sides. If we have the variable on both sides, those are the types of problems that we dealt with in our inequalities yesterday. Then we were solving. Okay, today we're going to add in, so that still can happen. Doesn't mean it has to, but it can still happen. But today we're going to add in that sometimes you will need to simplify one or both sides first. So before you start solving. So we remember that keeping simplifying is kind of like its own separate thing from solving. When we're simplifying, we're just doing what needs to be done on one side or the other side, or if each of them need their own type of simplifying, we treat them separate of each other. When we're solving, that's when we need to start doing the same thing on both sides. So we have to keep that straight again. So what kind of simplifying needs done in this first problem we have here?
Distributive property.
We need to do a distributive property. We have 5 times, in parentheses, 2 minus x. So to be able to get rid of those parentheses, we have to do distributive property. And same thing on the other side. There happens to be some simplifying to do, some distributive property. But before we do that, we're going to change subtraction to
Addition.
add the opposite. What can we put in front of that? X.
1.
We can put a 1 there, can't we? Should we slip a 1 in there and make it a negative 1x? And then is greater than or equal to 3 times in parentheses. We could put a 1 in front of our x in that one too, couldn't we? And then plus a negative 2. Okay, each of these are going to be done separate of each other. It's not like we have to worry about, okay, well this is what happened over here, so this is going to happen over there. So on the left side, we're going to take the 5 times the 2 and the 5 times the negative 1x. So 5 times 2, 10. 5 times negative 1x.
Negative 5x.
Negative 5x is greater than or equal to, and by the way, even if there was a negative number out front there that we were distributing with, we are simplifying, not solving, so we don't have to worry about the inequality symbol. So that's only a rule for when we're solving, but thank goodness neither of them are negative anyway. 3 times 1x. 3x. Plus 3 times negative 2.
Negative 6.
Negative 6. Okay. Is there any other simplifying we can do?
No.
What is another possible thing we could look for? When I talk about simplifying, what's another possible thing you could look for?
If there's a
Rose, what do you think? We would look to see, well, no, so you're starting to solve for me. Okay, I want to know if we were going to look to see if there's any other simplifying to do. Do you remember what the other simplifying step is besides distributive property? What do you think it is, Brighton?
I don't know, but is it because if there's 2 of the same signs on the same side?
Yeah, if there's like terms on the same side, if we look to see if we can put some things together. So are 10 and negative 5x, are they like terms?
No.
No, they can't be put together. How about that 3x and that negative 6? Are they like terms?
No.
No, they can't be put together. So now we could say we are ready to solve. Now we're ready to do the same thing to both sides of the inequality. So what are we going to do? Who wants to offer up what they think we should do here? What do you think should be the first move here? What do you want to do, Isaac?
Subtract 3x on both sides.
Subtract 3x from both sides? Okay. Did you want to make it a different move, Trey?
Add 5.
You want to add 5x to both sides, okay? And so what's your reasoning, Isaac, for why you want to subtract 3x from both sides?
Because then the x is not going to be on the right side. It's going to be on the left.
Yeah, that's a good reason. The x is going to be on the left side if we move the 3x. Okay, what's your reason, Trey, for wanting to move the negative 5x instead?
None of the variables will be negative.
Then you wouldn't have to deal with any negatives. So are either of these guys wrong? No, both of them are right. We could do either or, it does not matter. Does not matter. So it gets to be your call. Isaac wants the variable on the left so he doesn't have to worry about it at the end. Trey doesn't want to have to deal with negatives, you know, the fact that it'll be negative. So why don't you go ahead and solve this and see what happens. You get to pick. Which one are you going to do? And I'll do both of them. So you need to pick out which way did you do when you're verifying if you did if you did a good job with it. I'm doing it 2 different ways here. So you pick out which is the one you did and see if you can
And did we have to graph them?
Yep, we are going to still graph today.
This is easy to graph on, that's just
I think that's neat.
Well, annoying or not, we are going to do it. So annoying does not mean hard, does it? Well, okay, that's good. So did everyone end up with a solution x is less than or equal to 2?
Yes.
So notice, either person who did it, Isaac, by moving him to the left side, he had the variable there on the left side in the end, right away when you're done solving, but he had to remember that when you divide by a negative, you have to switch the sign. The way Trey did it created positive x's, but then the x is on the right side of the inequality in the solution. So that the x could be over on the left side, that's where he didn't have to do a reversal because he didn't divide by a negative, but you have to do a reversal to get the x on the left side. So we all should end up with the same answer in the end. Anybody have any questions about this one? About any place along the way it didn't work out for you? Hopefully this is what your graph looks like also.
Yes.
Okay. Okay, no questions about it then? Okay, then let's move on to number 2. Do we have any simplifying to do in number 2?
Yes.
Which side?
Left.
So we don't have any simplifying to do on the right side?
No.
No, only on the left side. So we're simplifying, we're not solving, we don't have to worry about doing the same thing on both sides. First step I'm going to do is just change my subtraction to add the opposite. And then we're going to do our, what's that property called we have to do on the left side? What's that property called? Distributive property. So then we'll do our distributive property next. Okay. You have the same statement I do. 2m plus negative 6 is less than 3 plus 3m.
What's it equal to?
I don't think there's an equal bar in there, is there? Emerson,
Do you want us to show all our steps?
what do you mean by show all your
Like,
steps?
you know, on the third row where it says 3 plus 3 and.
Mhm. I just brought that down.
Okay.
Yeah.
Oh, okay, never mind.
Yes.
It's-
Okay. So again, we get to make the decision now, we always move the variables first. So what would be one of the moves we could make?
Subtract. Add the 6.
I want to move the variables, Malcolm. Let's make that our first move. Can you tell me which variables to move instead first? Doesn't mean you can't move the 6 first, but I get a little crazy about that. You guys sometimes lose track of it along the way.
You can move negative 30. Minus 30.
You can subtract 3m from both sides. Okay, that's one move we can make. We can subtract the 3m from both sides. JC, what's the other one we can do?
Subtract 2.
We can subtract the 2m from both sides. So it does not matter which one we do, does it? Okay, so this is going to kind of create the same scenarios we talked about before. If we subtract 3m from both sides, we're going to create a negative number of m's. If we subtract 2m from both sides, we're going to move the variable over to the right side, but we'll have positive ones at least. Okay, so again, go ahead and solve this according to the way you want to do it. Whether you want to do the moving of the 2m's first, or you want to move the 3m's first. So, I'll do them both, or Dakota, are you done with one of them?
Oh, I've never opened.
You're all done with it? Malcolm, are you all done with it?
Yeah.
Are you willing to come up and show your work up here? Which was the one you moved, which m's? You moved the 3m's, right? Yeah, you want to come up and show us? I'll help you. Come on up, Miss
How do you do
Phillips,
that?
help you. Come on. Okay, well, we only have one up here at a time, so we'll let him do his first. And then we'll see. So, did you move the 2m?
Yeah.
Right? Or did you do, you moved the 2m also?
Okay, so we're gonna just
You
start
did
this
too.
step first.
I know what
you
you're
do.
doing.
You minus 3. Sure.
I'm getting
Minus 2.
Do what?
I'm following those.
And get them right? You guys sit down.
I don't know about that one. Little decimals.
I'm gonna show you guys a little trick of it.
The board's freaking out.
It doesn't like the pen.
Oh,
You need to use your
use your
finger.
finger.
No, I'm sorry, just
Oh.
pretend your finger is like a pen.
Here, this is what you can do. Here. No, that's not.
You can't get a board that likes everything.
See, you're doing great. Now I'll teach you. That's your 6.
I want you to find somebody in the room to compare your answer with while we're waiting. Find somebody in the room to compare your solution with while we're waiting. Probably your table partner would be a good person too, because they're right there. If you don't have a table partner, then you can find somebody close to you.
You gotta squeeze in there. So you gotta make it look like. And then you're switching these. Good. If you look at your paper, you got the answer there. Good. See?
Awesome, thank you, Malcolm and Mrs. Preston. Way to go. Okay. So, volunteer who did it by moving the 2m's.
That is a -9. The negative just got a little low.
That's a -9, okay, right here, this is a, oh, okay. So, this is a,
Yeah.
can I just make it so the symbol is, and we can see it like that? So that's the solution? Okay. JC, why don't you come up and do the moving the 2m's? And go ahead and just, let's change your color to red now, and just use your finger. So, do those of you in here who are waiting agree with Malcolm?
Yes.
I think you're gonna need it because we're gonna get 9.
No, but you still got the same answer. If you're inequality, so we're going in the same direction as this. Okay? It says m is greater than -9.
Okay, did that just,
Yes, you're correct. Well, I think what happened is you just.
did I write the problem down?
What you're doing is, okay, no, go ahead. You're just showing all the
That's a lot.
extra little steps you did there. Okay, so it is less than. So there actually could be 4 different ways we could start this problem. But I'm having you guys start it one of 2 ways because typically students are more successful with them if they move the variables first and not the constants. So in reality, there are even more than these 2 ways that we're showing up here right now. There would be a couple of other ways also that we could go about it, and we still should get the same solution. Let me extend the page for you, so you get some more room there. There you go. You can just write down on that white space. We don't divide by the m, so JC, we
We
only divide by the 1. Yeah, we don't ever divide by the variable, just by the 1. Okay. So if you, oh, you don't want to erase it up. So if you did on your notes, you probably want to get that erased, okay?
I didn't understand because she told me to put an M on one of the ones
Well,
on
when you're
top.
subtracting, moving the variable from one side to the other, you have to.
Yeah, when you're adding and subtracting, you need it there, but when you're dividing, you got to divide by what the variable is getting multiplied by, and only by that number. Okay, so either way, they both got the same answer, whether we're depending on, and it, again, here's what happened, because Malcolm ended up with a negative number of m's by moving him to the left side. Then he, in the process of solving it, he had to divide by a negative and had to switch the sign then. Okay, JC and anyone else who did it this way, when they were doing it, she moved him over to the right side, so then did not have to divide by a negative number, but instead wanted the variable on the left side, so we got to reverse it when we want it on the left side. So it just kind of depends on, you know, what are you good at remembering that you have to reverse the symbol when you multiply or divide by a negative? If you're not, then you might want to do it so you don't ever create those negatives for yourself. Okay, so what would the graph of this one look like? Integer neighbor to the left.
Negative 10.
Negative 10. So if you don't have a graph on there yet, let's get it. What's the integer neighbor to the right?
Negative 8.
Negative 8. Open or close circle at negative 9?
Open.
Open. What numbers are part of the solution set then?
Negative 8 and above.
Yeah, those guys over to the right of negative 9. Negative 8 and all those other numbers that are going that direction. Okay. Okay, let's go to the back side, and we have one more we're going to practice. We have to be thinkers. We can't get in this mindset of, well, this is what I did last time, so this is what I'll do this time. We have to look at it in first process. Do we need to do any simplifying?
Yes.
No.
Are there any, do we have any distributive property we need to do?
No.
No. Are there any like terms to put together on either side?
No.
No. So is there any simplifying this one?
No.
No, there really isn't. Okay. So, but what I want to teach you is I want to teach you a little trick. Those of you, Dakota said to me, he'd already worked this one out, and he said, I'm not sure I have the right answer because I don't do very well with decimals.
I did both.
Yeah. So what I want to do is I want us to know that we can also rename this. You can get rid of those decimals. Anybody know how we could get rid of the decimals before we even start solving it?
By changing them to a fraction?
No, we don't want to even change them into fractions. You think you want to work with fractions?
No. Can we change
Yeah.
them to whole numbers?
We can change them to whole numbers. How could we change them to whole numbers?
Rounding.
Not rounding. Multiply, move the decimal point. So if we move this one's decimal point, then we have to move all of their, every one of them have to have that. So we can move this one, we can move this one, and then we move this one also. So we're going to rename this inequality as 24x minus 3 is greater than or equal to 3x plus 60. So I want you to I want you to recognize that sometimes you get to just rename things and you can make them friendlier to work with. But remember, we learned, whenever you multiply or divide, you gotta do it to every piece. So that's what we just did. We just really multiplied every piece by 10. And now we can go about solving this. Okay, let's subtract 3x from both sides. And what's 24x take away 3x?
21x.
21x. So 21x take away 3 is greater than or equal to 60. What should we do next?
Add 3.
Add 3. So now we have 21x is greater than or equal to 63. Last step, divide by 21. And our solution is,
3.
x is, do we need to reverse the symbol? No. Is greater than or equal to?
3.
3, that's right, there's our solution right there.
Still got it right.
And you can leave them as decimals and work with them as decimals. I just wanted to show you a friendlier way to get to work with this problem. Okay? Rose? You don't have to. Like you notice in this one I didn't, only because it was just kind of like simple subtraction. But you can. It's okay. So if you want to just stay in the habit of changing it to add the opposite, that's a good thing to do. Isaac?
What?
Okay. Will you
No,
use your
I
hand up?
said you.
Okay. So any other concerns?